This is video R8, and it's going to be a really quick review of some things that we do with rational functions. There are lots of things that we can do as far as solving rational functions and finding general stuff with rational functions, but let's just talk about the easy stuff. First of all, if I've got a rational function, it means that I have a function that contains fractions. There are a couple of ways to solve these. First of all, you could cross multiply. You could multiply the 5 times the x minus 4 and then multiply the 1 times x plus 2 and just solve that equation. But like lots of the other problems that we do, since we're using a graphing calculator, it's quite often easier to just graph this and find the point of intersection. So if I wanted to solve this by graphing, I can simply say y1 is equal to 5 over x plus 4, y2 is equal to 1 over x minus 4, and graph the two functions. Now, be careful. You always want to make sure that you are putting numerators and denominators, if they are not single terms, in parentheses. So both of these denominators would need to be in parentheses. So when we graph this on our calculator, y1 gives us this black function right here, and y2 gives us the blue one. So we're looking for any points of intersections on this particular function. And there happens to only be one. It's this point right here, 6.5. So the solution to my function here, if I am trying to solve this equation, is x is equal to 6. Now if I plug 6 back into this function, I will discover y always works out to be 0.5. 5 over 6 plus 4, 5 over 10 is 1/2, and 1 over 6 minus 4, 1 over 2 is 1/2. So I have both of sides of this equation equal to each other. My solution occurs when x is equal to 6. The other thing that sometimes we have to do with rational functions is to find the various stuff that we find with any kind of function. So let's look at the function f of x is equal to x over x squared minus 4. We could go into all of the details as far as how do I figure out by hand all of these different pieces of information. But on the EOC, you're trying to get this done in a hurry. So if I want to put this in my calculator and graph it, and again, remember, I'm always going to put this in parentheses since I have two terms down here. If I graph x over x squared minus 4 and I want the x-intercept, I'm looking for where it crosses the x-axis. So second calc 0, and it's going to tell me that that happens when x is equal to 0. It's this point right here. This part of the function never crosses the x-axis. This part of the function never crosses the x-axis. If I want the y-intercept, I'm looking for where it crosses this y-axis. To find that, second calc value, you know your x value is equal to 0. So in this case, we know y is equal to 0. So we have our y-intercept. A couple of other things you might be asked to find: horizontal asymptotes or asymptotes. You're looking for values that your function approaches on the outside edges but never quite gets to. And in this case, that asymptote is at y equals 0. It approaches this x-axis but never quite gets there. On this side, it approaches the x-axis but never quite gets there. So we have a horizontal asymptote at y equals 0. Vertical asymptotes, lines that it approaches but never quite gets to, they go up and down. So we have two of them. We have one here and we have one here. So if you look at the value there where that occurs, it's at x equals -2 and at x equals +2. If you want to verify that on your calculator, if you do second calc value there, and I put in my x is equal to, let's say x is equal to 2, when it comes over here to the other side of your calculator, it's going to say y equals, and there's just going to be a blank there. So you're going to know for sure that you're looking at an asymptote. Be careful on your graphing calculators. Remember that sometimes on these TIs, depending on how your window is set, this will come down here like this, and then it'll look like it goes right straight back up. It'll look like you have another straight line going up and down right there. That does not mean that the function actually does that. It simply means that because of the way your window is set, it doesn't see that asymptote. So if you see something that looks kind of funny like that, where the function goes down and back up, try changing your window and you can usually tell that there's actually an asymptote there. Or just do second calc value and put in that x value, and you'll be able to tell that it's undefined at that particular point. So just a few very simple things that we need to be able to do for rational functions for the EOC.